Hi everyone. Today we are going to discuss problem number 2 based on homogeneous linear system of equations. So you know what is homogeneous system. Homogeneous system is nothing but it is X is equal to Z, where Z is called as zero matrix. Means if in given system your RHS is a totally zero, then that system of equation we call simply that is homogeneous system of equation. When the RHS of equation is totally zero, then we called as it is homogeneous system of linear equation. Now let me start problem number 2 based on homogeneous equations. The problem number 2 is given as solve the following system of equations are given to you, that is a 2x1 plus x2 plus thrice x3 equal to 0. Next one is x1 plus twice x2 equal to 0, and third one is x2 plus x3 is equal to 0. You observe the coefficient of these guys. You observe the coefficient of x1 is a 2, coefficient of x2 is a 1, coefficient of x3 is 3 is there. Now in second equation you observe the coefficient of x1 is what is that here 1, coefficient of x2 what is that here 2, coefficient of x3, so x3 term is not there, therefore we can take its a coefficient as a 0. For simplification we can take its coefficient as a 0. You observe the third equation, guys. If you observe the third equation, in third equation the coefficient of x1 term is nothing is there, this x1 term is absent is there, that's why instead of x1 we take its coefficient is 0 plus x2 coefficient is 1 plus x3 coefficient is 1, and that is equal to 0. Now we have to solve this homogeneous system. Because of that you observe the RHS totally. RHS is what is that here 0, that's why this is a homogeneous system. Now we solve the homogeneous system by using echelon form or by using this method. Now the solution I am taking here, the solution of this matrix or this system of equation can be written as the matrix form of above system is Ax is equal to Z, where A is called as this is a coefficient matrix, where A is called this is a coefficient matrix. I am writing here A is equal to coefficient matrix. Also X is called as unknown matrix, and Z is called as a null matrix, or we called simply it is a zero matrix. And this is a null matrix, zero matrix and unknown matrix, and then we have to take here augmented matrix, that is combination of matrix A and Z. So this can be written as now in this way. This is a combination of matrix A is a 2 1 3, B second row is a 1 2 0, third row is a 0 1 1, and combination of matrix 0, that is 0 0 0, that is all elements are 0. And now further you have to taking this augmented matrix, you have to write the reducing augmented matrix into echelon form. Means once you make this augmented matrix, for simplification you do echelon form. So for that you have to reduce the matrix into echelon form. Now I am writing once again augmented matrix. Let's see. So the augmented matrix becomes, therefore augmented matrix as it is simply AZ. I am saying now AZ, that is a null matrix. So this is combination of is matrix A and Z. Means I am writing here 2 1 0. Next column is 1 2 0. There is no 0 because x2 term is a present is there, so that's why I am taking column number second as 1 2 1, that is 1 2 1. Column number third as 3 0 1, and combination of 0 matrix is 0 0 0. We have to reduce it into echelon form. So reducing above matrix into echelon form. by using row transformation only, row transformation only. By using row transformation only, we have to reduce into echelon form. So what is echelon form, and you know the what are the row transformation you have to use here. So we have to perform the first row transformation as R12. Because of that, first leading element should be 1, means in first row and first column position should be 1. So that's why I am doing the performation is here, that is a row transformation R12. So interchange only row R12. So AZ can be written as, this is only place change is there of row R1 and R2. So row R1 becomes now 1 2 0, and here is 0. Second row it becomes 2 1 3, and there is a 0. Third row is becomes 0 1 1, and here is a 0. Nothing will change in row R3. Now we have to make the second position, means second row, means leading element, we have to make below the leading element, we have to make this 2 as a 0. So for that we have to perform some row transformation is again here. So we have to perform R2 minus twice R1, R2 minus twice R1. So that will get augmented matrix AZ becomes, we have to change in only R2, but row 1 2 and 1 and 3, but row 1 and 3 remains still as it is. So I am writing 0 1 1 and 0, means there is no change in row. I am writing the first as it is. Now we have to change in R2, that is R2 minus twice R1, means 2 minus 2 into 1, that will get 0. 2 minus that is minus 4, means what will get 1 minus 4, that will get here minus 3. Now next element is a 3 and next element is a 0, that is R2 minus R1 by performing augmented matrix now in this way. Now we have to make this minus 3 is a 1, so therefore we have to perform here the next operation, that is the next row transformation. Simply minus 1 by 3 into what is that, here I am taking R2, means multiply R2 row by minus 1 by 3 only. So it will get augmented matrix AZ becomes, nothing change in row R1 and R2, means 1 2 0, and here is a 0. There is no change in R1 and R2, therefore I am writing these numbers as it is, minus 3 then 3, then there is 0. But change in R2 is there, guys, change in R2, because we perform here the operation is operation for row R2. So row R1 and R3 becomes same, means I am writing here 1 2 and 0, there is 0 is also here. Third row as it is also, so 0 1 1 0 1 1, and here is a 0 as it is, but change in which row? Now change in second row, multiplied by minus 1 by 3, 0 into minus 1 by 3 0, minus 3 into minus 1 by 3, it will becomes 1, and second term it will becomes minus 1, and here totally 0. Now we have to make second leading element, that is below the second leading element you have to make here 0. So how to make this element is a 0? How to make this element is 0? Let's see. So therefore we perform here the next operation, R3 minus R2 simply. We have to change in R3 minus R2 simply. So therefore this is A Z, that is augmented matrix. This can be written as, this is 1 2 0 and 0 as it is, nothing change in row R1 and R2, 0 1 and minus 1, here is a 0, and lastly we have to write 0 0 0, and all the rows element are 0, all the rows elements are 0 here. Now this is echelon form, this is echelon form of matrix, this is echelon form of a matrix, guys. And after reducing the echelon form, you have to just compare the rank, so what will be the rank is there? Now that is very simply, okay, so the last element is of a row, and I'm taking again R3 changes as there is some correction is there, because if we have to perform the row transformation, if we have to perform the row transformation as, that is what, this is R3 minus R2, then what we will get, nothing is a change in first and second row but change in third row, that is element is 0 and that element is what is that here 2, that is means 1 and minus 1, this will becomes 2 is 0. Now also we have to perform some row transformation, we have to multiply by row R3 by 1 divided by 2, means the last element should be equal to what is that here 1. So therefore the augmented matrix AZ becomes, that is 1 2 0, this as it is now. Also I am writing 0 1 minus 1, here is a 0 and 0 0, that is a 2 by 2, means what you will get here 1 and here 0, 2 by 2, that will becomes 1 and that is equal to 0. So since I have compared the rank of a matrix, since this is echelon form, I am writing guys here, this is echelon form, means nothing is a change in this matrix now, so therefore this is echelon form, so therefore we have to compare the rank of matrix is given as, rank of matrix is given as, how to given this rank of matrix, now let's see. So in a matrix you know very clearly, you getting the augmented matrix as AZ matrix, as that matrix is 1 2 0 and here is 0, the next one is 0 1 minus 1 and here is 0, and the last row becomes 0 0 1 and 0. You observe the matrix guys, here clearly number of non-zero rows are 3s, so therefore here rank of matrix A is equal to 3 and rank of matrix AZ, that is equal to also 3, and number of unknowns you also, and n is equal to number of unknowns is equal to what is that also 3. So therefore rank of matrix A is equal to rank of augmented matrix AZ, and that is equal to n and that is equal to 3. So therefore system possesses trivial solution, system has trivial solution means what is that, system has unique solution, unique solution means what is that, it is a clearly, hence the system has a trivial solution or the system has unique solution. So therefore x equals to 0, y equal to 0 and here z is also equal to 0. This is a trivial solution of a system, trivial solution of system guys, and this is your solution. I hope you understand this example very well and very clearly understanding here, and you have to enjoy this example guys. Thank you.